Hello, and welcome to this video tutorial. In this video tutorial, I will be discussing topographic hillshades. And topographic hillshades are very powerful approaches for visualizing what a landscape looks like by simulating how the sunlight would light up a landscape and the topography. So begin by discussing what a topographic hillshade is, and then I'll show you how to use the OpenTopography user interface to generate topographic hillshades. So here we are looking at a digital elevation model, or DEM. We see that it's colored in white and black, where white represents high elevation and black represents low elevation. And here you get a sense that there is a higher elevation in the center of the DEM in these white colors, and then lower elevation around. So this does look like a mountain. But we can get a lot more from this data by looking at the topographic hillshade. So here we have the hillshade, and this now shows us a lot better what this landscape looks like. Specifically, we can see that there is this northeast, southwest trending mountain surrounded by lower elevation landscape that looks like it has fairly active fluvial processes. And so again, this hillshade is looking at what the landscape looks like by shining the sun from a particular angle. We have two choices in making a hillshade. You can choose the azimuth of the light, so that's the cardinal direction where the sun is going to be coming from. Often is entered in degrees from 0, which corresponds to north, all the way to back to 360 degrees. And we also have the option of the altitude of the light, where 0 degrees indicates that the sun is basically horizontal to the landscape, and 90 degrees, the sun is overhead. And when you're making topographic hillshades for a variety of applications, it's really, really important to visualize the hillshades from different azimuths, as these really show the landscape in a different way. And it's also important to look at different light altitudes, specifically for certain mapping applications, as these different light altitudes can show subtle features in different ways. So the next slides, we're going to be looking at how this area and a different area look like with different light angles. So first, we're looking at the light azimuth. And again, this is the cardinal direction of where the sun is coming from. And here we're still looking at that same mountain. And this is shown with the light coming from a cardinal direction of 315 degrees, so the northwest. And this is often the default in many types of software. And here, this angle, we see features that are going to be perpendicular to this 315-degree angle very well. In other words, northeast to southwest trending features. And so we see this mountain very prominently. And also the white colors, or the lighter colors, for example, here, these are slopes that are dipping or leaning towards the northwest, towards the angle of the light here. And the darker colored slopes are angled towards the southeast. Here's another topographic hillshade. In this case, the light is coming from the southwest with a 225-degree angle. And here we see that the mountain does look different. We don't see quite as prominent of the northeast southwest orientation, but instead we see more of the topography within the mountain and the southwest and northeast slopes more prominently. For example, this white area here, or lighter color area, represents a slope that's leaning towards the southwest, and the darker colored areas represent slopes towards the northeast. And here is the topographic hillshade with a light angle from 45, this being the opposite of 225 or 180 degrees apart. We're going to see similar features in the landscape, but colored the opposite. So features that were light colored in the 225 are now going to be dark in the 45 and vice versa because the sun is 180 degrees apart. Or again, like the 315, we do see this prominent mountain range, but in this case, the southwest or the southeast side is light and the northwest side is dark. And so in summary here, we can see the importance of calculating and visualizing the landscape with different azimuth angles, as these azimuth angles really do highlight different aspects of the landscape. Here we're looking at the San Andreas Fault in California. On the left with a light altitude of 20 degrees, and on the right with a light altitude of 70 degrees. We do see different colors in the hillshades, but if you look in detail at the features, the fault here, which stretches approximately in the center across the length of the image, does look different. And in particular, the majority of the fault is quite nicely highlighted here in the 20-degree hillshade. But in the 70-degree hillshade, we do get better definition of the fault in certain areas. And again, this highlights the need to make topographic hillshades from different light azimuths as well as light altitudes. So now I'm going to show you how to make a topographic hillshade using OpenTopography. So you want to begin by going to opentopography.org. We always do recommend that you make an account, which you can do by clicking Getting Started and scrolling down to create an account. And once you've done that, you can go to Data. And this opens on this default page, highlighting the data sets that are available in the United States. But for this example, we're going to zoom to Philadelphia. All right, here we have Philadelphia, so we can see that we have these green data sets, which are USGS 3DEP, and blue, which are NOAA. And for today's example, I'm going to process right in the center of Philadelphia. So we can go to select a region on the left and then draw the box. This highlights the data that we have. And for today's example, we're going to be looking at this Delaware Valley data set, which is accessed through to academics as well as through the OT Plus subscription. So we'll click on Get Point Cloud Data, which takes us to this page. We can see the area that I selected. We can either keep it as is or use this blue button to select a different region. And then below we have our standard options, coordinates and classification, which we can leave unchanged. But then to make a hillshade, you do want to come down here to window number 5, raster visualization, and then you want to click hillshade. By default, OpenTopography does not make hillshades, so you do have to click this button to get and visualize a hillshade. And then you have these options here. You can add a vertical exaggeration, or the altitude of the light source, or the azimuth of the light source. And recall 315 degrees is often the default here, which we'll leave. And then you can say submit. So now the job is processing at the San Diego Supercomputer Center. And here are the results. So we can scroll down. We have the options to download the point cloud file, the DEM, as well as the visualization products. And the visualization products include this topographic hillshade. And here we can see the topographic hillshade. We can click on it, which will open in a new window. We can then choose to zoom in and scroll around and see what Philadelphia looks like. Alternatively, we can click here and say View on Map. So now this has colored satellite imagery, and we can zoom around and turn off the hillshade, see what the underlying satellite imagery looks like, and then turn it back on. this concludes our video looking at how to make topographic hillshades using OpenTopography.